Good day, everyone. Have you ever wondered how your emails, streaming shows, and online games find their way through the massive maze we call the internet? Well, today, our group will pull back the curtain on that digital magic, and we will introduce you to the unsung heroes of the internet, routers and switches. We will walk you through how they work and compare the two main ways they get data where it needs to go, the static and dynamic routing. But first, let me introduce to you the team that is here to guide you through this journey. We are Ronald, Reyjen, Bong, and Maria Karla Andrea Ubaldo.
Let's start with the first hero, the router. Think of a router as the traffic cop of the internet. Its job is to connect different networks, just like a major highway interchange connects different cities. It's the brain behind the operation, using IP addresses, the unique street addresses of the internet, to figure out the best way to get data to its destination. Its main functions are, first, choosing the best path. It's constantly looking for the quickest and most efficient route for data to travel. Second, forwarding packets. It sends data packets, small envelopes of information, to the next stop on their journey. Third, dividing networks. It breaks down large networks into smaller, more manageable subnets. Fourth, providing NAT. It helps connect your home's private network to the public internet, acting as a translator. And fifth and last, offering firewall protection. It acts as a security guard, keeping unwanted visitors out of your network. Just like roads, there are different types of routers for different jobs. 1. Core routers. These are the massive, high-speed interstate highways of the internet. They're found in the backbone network of major internet service providers, or ISP, and handle huge amounts of traffic. Second and lastly, edge routers. These are the local roads that connect your personal network to the internet. They sit on the edge of a network and are your first point of contact with the wider digital world.
Next up is the switch, a different kind of hero, while the router is the traffic cop. The switch is more like the main sorter inside a post office. It connects multiple devices, like your computers, phones, and printers, all within the same local network. Instead of IP addresses, it uses MAC addresses, the unique serial number on each device, to send the data exactly where it needs to go. Its main functions are forwarding frames. It ensures that data frames are delivered to the right devices inside your local network. Preventing loops. It uses a protocol called FTP to prevent confusing data loops, ensuring a clean and efficient path. Next is dividing traffic with VLANs. It can create smaller visual networks VLANs to keep different types of traffic separate and organized. Next is keeping a MAC address table. It maintains a detailed list of all the devices on the network so it knows exactly where to send data.
Now that we know who our heroes are, let's talk about their strategies. Routing is the simple process of choosing the best path for data to travel. There are two main strategies, and these are static routing. This is like a hand-drawn map. The network administrator manually sets out all the routes, and they don't change unless someone updates them. It's a set it and forget it method. Second, dynamic routing. This is like using a modern GPS. The routers automatically communicate with each other, sharing information and adjusting their routes in real time, based on network conditions. They use special languages called protocols like OSPF, RIP, or EIGRP. Think of it this way. Static routing is like having a reliable, unchanging schedule. It's simple and predictable, but if a road is closed, we're stuck unless you manually update the map. Dynamic routing is like a self-driving car. It automatically reroutes itself around traffic jams or roadblocks, making it incredibly adaptable and scalable for huge networks.
But methods have their strengths. Number 1. Statistic routing is a great for small networks because of its simplicity and security. It has minimal overhead since the routers aren't constantly talking to each other, making it very efficient. Next is dynamic routing. Shines is larger, more complex network. Its main advantage are automatic adjustments, capability, and the ability to find the most efficient path and even balance to load across multiple paths. But there are also trade-offs. The biggest weaknesses of static routing is that it's not escapable. Imagine trying to manually map every single street in a major city. It will also lack redundancy if the path goes down. Data can't automatically find another way. Next is dynamic routing. It's more complex to set up and requires more resources. And because it's automated, administrators have less direct hands-on control. Let's bring this all home with some real-life examples you see every day. Your home network, that Wi-Fi router you use, is a perfect example. It's the Tropic Cup that connects your home networks, your phone, laptop, smart TV, to the rest of the internet. The little ports on the back of your are built-in switch that connects your wired devices. A university campus. Think of the routers are the main gates that connects the entire campus to the internet. Meanwhile, powerful switches inside each building connect all the computers, servers, and printers, making sure the data gets to the right students or professors' desk.
To wrap things up, remember these key points. Routers connect different networks, acting as the intelligent traffic cops of the internet. Switches connect devices within a single network, acting as the efficient mail sorters. The source between static and dynamic routing is all about the right tool for the job, whether you need the simplicity of a fixed map or the adaptability of a real-time GPS. And now, thank you for joining us on this tour of the digital highways and byways. We hope you now have a better understanding of the devices that make our connected world possible. And that is all. Have a nice day.